Good afternoon, everyone. Thanks for coming. My name's Roberto. But before we talk about me, let's just get this clicker working, actually. It was working 5 seconds ago. Ah, yeah, it's working. Yay. Great. Before I talk about me, I want to present my team. And it's weird, this clicker. It's the batteries. The laser is working, but not the. OK. I'll just do it the old-fashioned way. Or, no, I just have to click really hard. OK. So before we talk about me, I wanted to talk about my team. So they're the ones doing all the work. They show up every day with dedication, ambition, and an open mind. And they push each other to greater heights. So I'm really grateful to work with each and every one of them. And yeah. Jesus, this clicker is really something. 1 second. I think I might just switch over to, it's like, OK. That's me. My name is Roberto Flores. I'm leading the data engineering team for Europe at Unilever. That's my mom. And the city behind me is Rotterdam, where my team is based. I'm just going to go without the clicker. OK, so today we're going to talk about a few things. It's a lot of boxes, but don't worry. I'll walk you through them. First is the context. So why did we do Blueprint? And what challenges were we running into? Then what were the main design principles we agreed on as a team? And then, of course, how does that translate in an actual code repository? Once the repo is done, how did we turn that into artifacts that are then distributed across our environments? And finally, there's a bit about our broader ecosystem, because we are more than just a set of resource groups on Azure. Like our whole estate goes into, for example, PowerBI or D365. There's also one of my favorite bits, which is about people and how we enable what I call self-service engineering. And finally, well, it's quite a big party in Europe, so how do I keep things from going out of control? So some context. Actually, that slide doesn't show it very well, but there's a few. There's another one where you can actually see things. So Unilever, we are a large company. We produce goods that are used by 3 billion consumers every day. Our operations have many stages. So we purchase raw materials, we manufacture our goods, we distribute them to our DCs that then go to the consumers, to the customers, the retailers, and finally to consumers. On top of that, we also do marketing activities. So there's a lot going on. And that means there's also a lot of data points. And because of the different nature of all the activities Unilever does, all those data points have different shapes, sizes, formats, and so on. So I'm actually going to switch to the other slide, because it's anyway, at least it's visible. So on the left side, you see our enterprise data sources. And there is a unique landing area called UDL. It's the thing you see on the top left. It's called Universal Data Lake. So that's a full fidelity copy of our data sources. And it serves as a single source of truth. If anyone's ever used raw SAP data, you know it's not exactly something you can plug into a dashboard and just answer a bunch of questions. So we also make something called BDL, which stands for Business Data Lake. And that's actually segmented by function. So we have one for marketing, one for supply chain, one for finance, and so on. So we actually grab the raw data in its less usable state, and we sprinkle some function-specific but use case agnostic transformations. And then further down, but a bit below, you see Market Data Lake. That's my team. So Unilever, the way we operate, we're a global company. We're in 190 countries. But the way we make decisions and actually operate the business is at a regional level. So in the case of Europe, we do Europe, Australia, and New Zealand. And Australia and New Zealand, for some reason, indeed, I was saying in another session that I think is because of Eurovision, that competition. Then further downstream, we have our Power BI Premium estate. That's where we have most of our reporting. And bridging the two, we have Databricks SQL Serverless or Synapse Serverless, depending on the use case. I can go into that more later. OK. So what did Europe look like 2.5 years ago for Unilever? It looked a lot like the left side. So the left side, you see a few hotspots. That's basically UK, Benelux, and France. Those, before a big transformation we went through 2.5 years ago, Unilever was managed at a country level. Now we're doing it at European level. But because it was managed at country level, that meant every country had a different data maturity level. We had some hotspots in UK, exactly Benelux and France, but the rest of Europe was a bit underserved. So when we became a European team, we had the mission not just to raise the entire organization, but also to cover for everything that was not being covered. Also, the data itself in Europe is very complex. It wasn't just Unilever making decisions at a country level, it's also sometimes the data we get from certain providers. So for example, we had once this exercise to do market performance. It was done in parallel in the US and Canada, as well as in Europe, which sounds pretty equivalent, right? So as a market, they are pretty equivalently sized, at least for us. What happened was that the North America team had to go through what's called 10 DG cells. So that's actually like sort of like an internal decision-making cell. And they had to go through something like 20 databases to cover all of our most important markets and one official language. But in Europe, we had 38 markets, 24 languages, 129 DG cells. And for that same exercise, we had to go through 316 data sets. So there's complexity organizationally from history. There's complexity in the data. And there's also complexity of layout. So it's when you move into an apartment and there's a furniture there that you don't really like where it is, but actually it's going to need some work before you renovate the kitchen. In this case, as I mentioned, there were 3 sort of mature teams. They had, in combination, something like 13 resource groups. And all of these things had live products on them. And it's not something I can just switch off and put into one. There's people behind, there's people depending on these products. So that's another complexity that we had. And then we sat down together and we said, okay, if I am going to be a Europe data engineer, actually I might need to, maybe I'm the East Europe guy and my main products today are in EU1. But imagine my French colleague goes on holiday on EU7, and you have to suddenly switch from one resource group to another. When they both were using completely different practices, that's a bit of a nightmare. You have to go into a data factory you've never seen to troubleshoot a pipeline that God knows how it works. So there's a lot of issues in switching costs. The worst thing you can do to an engineer, software engineer, data scientist, is do switching, context switching. Because you really want people to focus and be creative and be at their best. But as soon as you do some context switching, you really sort of reset people. So we really wanted to reset, change how we worked. And I sat down the team and I said, okay, I understand we have a lot of complexity, but that gave us a lot of strength. Because let's say the UK team was very good at APIs. The France team was very good at picking other types of data sources and so on. So we said, okay, let's get together, let's pick up the best, and let's decide, let's have a personality as a team. What we said was, we want to go into EU7, EU6, EU13, 15, and that when people look at it, you can know it's the same team, same personality, same things. So we decided on the most important things, 2 of them. So first one is workflows in general. So how do we schedule things? How do we configure some of our Spark workloads? And the other one's tooling. But this side is going to focus on the first one. We're going to check the other one soon. So what does our framework look like? The other thing that was important is I wanted to do it in a tech-agnostic way. So we wanted to, today, use Data Factory, but if tomorrow, something like actually the announcement of today of Databricks workflows looks very nice, that we're not locked in. So the main design decision was that the data would sit in a component that is independent. So the metadata sits in Azure SQL database. Then we would have whatever would use that metadata on the bottom would do lookups and execute on what the metadata instructs. And we also had, of course, things like getting the thing into PowerBI and Teams. And I'm going to go through this for Data Factory, which is what we mainly use today. But the principle should hold for any other thing. So, for example, we'll try out lake flows. The other thing we wanted was if I went into one environment, there was one way of writing a delta table. In the other one, there was another way of writing a delta table. I can go on. But we said, OK, what are the main activities that we want to standardize? Because there's also such a thing as too much standardization. So we said, OK, let's just pick our battles. The one is definitely onboarding data, so how we onboard data. There were, I mean, if you have something like 10 SFTP pipelines, I mean, come on, how different can they be? Then you have, of course, UC management. Another thing we decided as a team is that regardless of the team or the environment, we would have one Unity catalog that forced us as a team to negotiate and decide as a team what we put out there. So there is one exchange rate table. There is one product category hierarchy. There's one customer hierarchy. So these things are things that as a team you need to, again, have a personality, be consistent. This is our master data. And we have things for that. Then finally, as I mentioned on data estate, so Power Platform is a thing. So some people in Unilever like making Power Apps. And then Data Factory is what we'll go through. So these are things that we then distribute across environments as artifacts. I'll go into those later. Now, what does the database look like? And there's a key definition here. That's actually what a flow is. And the flow has, of course, attributes like which subscription is this running on, which resource group, is this onboarding data? If so, what does the data contract have? And if it's failing, where do I send the communication? So these types of things, basically, it's like a database, right? A relational database. What do those things look like then from a high level? So a flow basically has 3 stages. One where you onboard a data set. If your pipeline has I don't know, an API, imagine you have to pull data from an API and then do some transformations and then refresh a dashboard. So staging is where we hit that API with some HTTP requests. Then the layers are basically scripts or notebooks that have to run on that data that you just onboarded. And finally, well, if something goes wrong, you want to send a Teams notification. We initially had email, but actually we were being spammed with emails, and we actually said it's a bit more reasonable to use Teams. And then you just put a Teams notification. You can tag the engineer there. It's a lot more manageable. And finally, of course, once the data, everything goes well, you want to refresh the Power BI dashboard and refresh like only the partition that you want, and so you don't refresh the whole thing. Let's go into the first part. So this is staging. Staging, as I mentioned, is basically onboarding a specific type of data. And as I mentioned, like you can have a few different nuances to SFTP, but I mean, how different can they be? So we made a use case agnostic SFTP pipeline. And on top of that, you see the first thing in every single pipeline is a lookup. So the lookup is basically going to the Azure SQL database, looking up the specific flow you're running, picking up the instructions, the metadata, and then executing the instructions on the child pipeline. And then the child pipeline looks like this. Again, you look up the contract because a flow can have many different data sets. So you can actually hit 2 endpoints of an API, for example, where each contract hits a different endpoint, and then you bring in 2 objects, let's say. So each child pipeline will look up the specific contract. Well, in this case, sorry, I keep jumping from API to SFTP. Let's go back to SFTP. So you look up the contract. You, in this case, go into the SFTP, into whatever folder the contract said. You look for whatever naming criteria you're looking for, or file type. And then when you find your file, you land it if it's been modified within a certain time. And finally, you onboard it. What is onboarding? Onboarding is basically, you know the concept of autoloader, right? But we have a lot of different file types, and it's a Python class that you can use to onboard anything from JSON, of course, to CSV, Parquet, Excel files even. So this basically, just like autoloader, brings in the file, logs if you've already processed that file, and then writes it into Delta. And there are, of course, for reading, common operations, but for writing as well. I mean, you can decide on the layout, and you specify that this is actually a contract on the slide. You see it's, this is actually a SharePoint file, an Excel one. And in this case, it's basically saying load type is F. That means it's a full overwrite. So every time it pulls the file, it's just going to overwrite whatever is there. So we just have different, you specify the load type as per the situation. After you onboard the file, you brought in that file, you brought it in. It's now a nice bronze Delta table. You then have, of course, maybe a few transformations to do downstream before you can actually refresh your dashboard. And that's when we have this layer part. So in the layer part, you put basically the order in which you run different subscripts, right? And some of these scripts might be heavier than others. And some of these scripts might have ability to run in parallel. So here, for example, you have, in the diagram, you have one running on a light cluster, then two that we said, okay, light cluster, but put Photon on it because we saw an ROI. And then the final one, we do a heavy cluster because, I don't know, it's doing a big join or whatever. And this is a bit what the layer part looked like. So again, so staging, layers, and this is the layers part. Now, we'll go into the API thing and into the email part and the PowerBI part later. But I just want to show you what this looks like. Again, I was showing a screenshot of a file a few seconds ago, but this is then what the repo looks like. There's a separate repo just for metadata. It's called whatever the name of our ITSG and then the blueprint. And it has basically a folder called flows, a folder called schema, and so on. Let's go into each of them. So the flow file, as I mentioned, has what's running. So a specific flow has a name. In this case, it's a flow for a DACH retailer. It's a retailer that sends us data every day. We put in the contract the details of how we land that data with the retailer. So I think in this case, it's an SFTP, see? And it's an SFTP that has a CSV. That CSV is semicolon delimited, doesn't have a header, and so on. And then after that, we actually specify, I think this is even from that same retailer, some transformations that have to happen after we onboard the data. So the flow basically says where it's going to run. So you see some attributes like the connection ID. That can change depending on if it's dev, QA, or prod. Likewise for of course, the Azure info, like which database is running things and so on. Then we go into the schemas. So the schemas is basically foolproofing the solution. So this is just testing if people filled in the YAML file correctly. If I go in and I fill in some funny thing that's not allowed, it's just going to not let me even merge the pull request. So this is just foolproofing. Then the onboarder, as I mentioned, we read different files. We log if it's been onboarded or not, depending on the different thing. It's a Python class we call Kiln. One of our engineers is very fond of barbecues. And then, that's where we store that. And finally, not finally, next we have data quality. Data quality, we really like something called the gray expectation. So that's what we're looking at for data quality. You can set custom rules, and you just basically specify which rules apply to which data set. Then finally, we have, actually, in this case, we have Unity Catalog. So this is a big one. We actually had another talk 2 days ago, and it's very important, especially now with Genie coming up, to control and make sure that the most important data sets have your expertise put into it. Because it's great to depend on the automatically generated one, but for the key core data sets, you know that data better than anyone. So when you populate that metadata, you can then ensure that the Genie will populate any surrounding tables or dependent tables properly, or better than it would otherwise. We also manage things like access on UC here. So if there's a schema in our UC, and inside that schema there's a volume, we say which AD group has access to that volume and which type. There's an init script. This is important because we use some Python packages, and this ensures that when the cluster starts, the package is installed and knows what to import. And as I mentioned, this is the environment-specific metadata. Maybe in my API, for example, if I run that on a dev environment, I don't want to run it on the prod endpoint of the API. I just want to run it on a UAT. So there I can say, well, listen, if it's dev, you run it on this, and so on. So this basically puts all the landscape-specific information, like the context. Now, let's have a look at the artifacts. How does it work? So as I showed you the data engineering subfolder, and in that repo, you can configure YAML such that it listens at a specific subfolder. So if a pull request comes in that changes a specific subfolder, and that thing is merged, you can actually trigger a build for only if something inside that subfolder changes. So we actually have the listeners for the data engineering part, the data science part, which is work in process, and also the data analyst part. So that goes to 3 separate artifacts. And that's actually the YAML. We use something called Twine. Yeah, we use Twine that publishes a wheel, and the wheel goes into Azure DevOps where it publishes an artifact. This is what it looks like. So if you go on Azure DevOps, you click artifacts on the left side, then you find Blueprint and all the versions. That's actually in turn specified in the flow, so you can then say this pipeline runs on this version of Blueprint and so on. That prevents it from. The other thing, well, as I mentioned, one of our biggest pains was actually data factory. One thing we really wanted to avoid was that if I go on holiday, I'm at the beach, we want to prevent calling people while they're at the beach. So to do that, it's very important that we understand each other's work. One of the main black boxes that was going on was data factory. We were seeing left and right things that we were just spending too much time deciphering other people's work. So of course, when we standardize our data factory pipelines, this really helped. And then this helped keep that standard pipeline in sync. So we have, when you run a data factory deployment, there's the regular ADF ARM template that you deploy. But on top of that, you can use another artifact, which is the one that we have for Blueprint. And then basically the release turns off the trigger, deploys the local ARM template, runs the post-deployment script that cleans up, finally runs the Blueprint ARM template that feeds in the standard pipeline. That ensures all the environments are in sync. How does a pull request look like? So for our, as I said, this causes then a dependency for, so if someone breaks that, it actually you can break a lot of stuff. So we make sure that our PR process has a lot of checks. One is just basically linting, so we do a check on the Python code if it's PEP 8 compliant. The other is on stability, so we have, of course, some testing that's done on the class whenever something changes. We have some use cases of what can definitely never break. And finally, of course, a senior data engineer has to review. Once that's approved, the artifact is created and a new version of Blueprint is born. Okay, let's have a look at the rest of the data estate, actually. Because I mentioned we are more than just some resource groups on Azure. We actually are, in Unilever, one of the largest users of PowerBI globally. And that means we have on our PowerBI's workspaces, we first have a lot of PowerBI workspaces. So similar to those resource groups that I showed you, we have a similar situation with the workspaces. So we also needed some tooling to keep that under control. And also, just to manage usage, right? Because that's a thing. You can actually have like a lot of dashboards but no one's using them. So we were really keen on really understanding, are people using our stuff? So we went through the flows. That final step was basically shooting. So this is just basically a continuation of that. So after the flow finishes, we just use the Enhanced API or the XMLA endpoint to refresh the PowerBI dataset that's relevant to that flow. That's for orchestration. But we also, as I said, we want to measure usage. And we use the same API to actually pull in usage from the PowerBI Premium Workspace. There is a specific query that we run on the workspace that we use to pull the usage for every report. And we actually keep it as an extra object in our data lake. We then actually match that with cost, which I'll go into later. We have the other thing in terms of an ecosystem is our D365 integration. So a lot of people like to use like Power Apps, things like Dataverse. So we made a D365 enabled service principal that can send out data both ways, actually. So we can import and export data, and also helps us manage that part a lot better. If you're making, for example, a table on D365, you can either do it on the UI, which is a nightmare, or you can do what we did in the end, just, again, following our pattern. YAML file, you put the name of the table, what the unique column ID and the types. And actually, you can then create the table with the API instead of that UI. And it works very similar, right? So that goes into SQL, and then the thing runs, and so on. And data goes, again, inbound and outbound. So you can create the tables, but you can also put a staging. We literally have just a staging pipeline for D365 where we put the metadata, what's the table name, and so on. And that pulls it in, and you can put it at the start of a flow. So that's how it comes in. But we also use this for things like mappings. So sometimes we have some very locally maintained mappings that are like not really that robust. So the way we keep them up to date is just some users. If there's a new code that comes in, there's this Power App that automatically populates like, hey, there's an unmapped code, fill it in. And that is actually automatically populated from our normal pipeline. There's just a delta table that measures if there's anything unmapped and flags it there for people to use. So we actually have data coming in and out for that. My favorite part, self-service data engineering. I know it sounds dangerous, but yes, I love it. So I have, of course, a lot of business users or data-savvy business users that want to do stuff. I mean, think a digital commerce team or someone that just wants to make things. So we really want to give people tools so they can use their data foundations. And actually now this Genie is, I was really happy when they announced that. But sometimes they actually have to bring in their own files. So maybe they even negotiate on their side with a vendor, an SFTP delivery or something. So the way contracts work is actually, they can also fill it in. I mean, it's literally just filling in a YAML file. So they can fill it in, do the PR, a data engineer will review. There's a linting test just to make sure they don't do anything weird. And if the test pass and the code review pass, then actually that goes. And they can actually run that on our data foundation. And of course, we keep track of it because when someone runs a flow, we also add some cluster tags for things. And this is a screenshot of our dashboard, let's say. Whenever a flow runs, the data factory thing creates a cluster tag. Then that cluster tag flows into the system tables of Unity Catalog. And you can actually pick that up from the UC and see the cost. And not just the cost, even the cost after discounts or the cost after like the actual cost. So this allows me to have the cost per activity. And even better, if you put them together, remember I mentioned before that I actually also bring in the PowerBI usage. You can then have the cost of that specific activity and the usage behind it. And that allows us to make a lot of good decisions. And we also use UC now, especially for, there's a lot of people in our SQL environment. And this allows us to see, well, is it being used? And is anyone doing something weird? Is there a query that's taking too much resources? Things like that. So this allows us to keep an eye on things. Cool. I see I have exactly 10 minutes left, which is what I wanted. So great. I'll take questions if you have any. Thank you.